I interviewed a couple hundred people, even went to motorcycle meetups and showed them our roadmap of here's what we're doing. 89% of the people we interviewed said, I would love to have a mini truck. That ability to navigate the city streets, but also have the ability to take my kids to the beach, that doesn't exist. That's a huge need.
Hey folks, I'm Connor Gaughan, and welcome to Consensus in Conversation, a podcast that showcases the innovative potential of American entrepreneurship and how leaders are finding new ways to align purpose, profit, and sustainability. Today, I'm talking with Forrest North and Jason Marks, the co-founders of TELO Trucks, an electric vehicle startup that is redefining the future of urban automotive transportation. If you follow the auto industry at all, you know that EVs are everywhere, and they're here to stay, as consumer interest and buyer incentives have aligned with technology advancements and manufacturer investment to create a moment of unprecedented opportunity for the industry. Legacy automakers are building new facilities as they electrify their fleets, like the Ford F-150 Lightning, the Mustang Mach-E, and Hyundai's Kona electric SUV, emerging as some of the many options for buyers. These models are great, but they deliver a similar experience as their combustion counterparts. And then there's TELO. TELO is creating something entirely new to service a previously underutilized niche, that of the urban utility driver. Their design combines the high occupancy capacity of an SUV with the storage bed of a truck, and it all fits these features in the condensed footprint of a Mini Cooper. This smaller size allows their electric truck to more easily navigate narrow city streets, and its safety features will protect both driver and the surrounding pedestrians and bicyclists. After gaining experience as an early engineer at Tesla and then multiple-time founder in the field, Forrest brought a rich institutional expertise to TELO, where he teamed up with Jason, whose technology know-how and limitless passion combined to build a foundation for success. Speaking of building, you'll hear a bit of background noise today as Jason recorded from the R&D facility, complete with a TELO frame directly behind him. It's not every day that we get to witness the birth of a new mode of transportation, so I'm eager to learn more about its creator's vision. All right, let's jump right in. Thanks for doing this, guys. Super excited to have you both here. The company you're building is really exciting and really innovative, and I think folks are going to find it a fun episode. So, Forrest, start with you. Give us a little bit about yourself. Where are you from?
I'm from Port Angeles, Washington, which actually I'm in right now. Grew up in the Northwest.
And you go to Stanford. What did you study there?
I actually majored in urban studies with a focus in architecture and urban form. I took most of the product design core and ended up being a mechanical engineer pretty much after school in every job.
It looked like you got your start in the industry at school. So I wanted you to tell us a little bit about the Stanford solar car project.
Yeah, so I started off being excited about solar cars. Mainly, I grew up in a log cabin out here in the woods. I was very interested in alternative energy and alternative transportation. Built a little radio-controlled solar car in high school. Then when I got to Stanford, joined the solar car team. And that's really where my passion was. We raced in the Sun Race in 95 in the US. We came in third. We raced across Australia in 96. We raced in Japan 2 times. There's a project where it was hands-on, it was real, it used the sun's energy, and I got to travel around the world doing it. Everything I wanted. But I found that the actual engineering courses I was taking at school were maybe not necessarily for me. And so I was pretty interested in kind of a broad range of things. So that's why I didn't actually major in mechanical engineering. But then when I left school, all my friends were starting companies, and so I worked for them as a mechanical engineer.
As you look back, I'm curious if the urban studies angle, like if you find yourself thinking about that or applying that in hidden ways that you wouldn't necessarily have thought of, but that kind of resurface.
Oh, absolutely. I mean, every urban planner's biggest nightmare is parking. There's a lot of bike-centered movements in urban planning that I was excited about and studied. And the whole actual major was an interesting case study on why Silicon Valley succeeded over the Boston corridor, which was really kind of the technological center before Silicon Valley pulled that to the West Coast. So yes, I'm very excited about the built environment. It's a kind of a slow moving field that doesn't allow you to like get out there and build things and get them into people's hands.
When did the shift take place into auto?
Yeah, so after the solar car team, they were crushing all the electric cars when I graduated. So it was really dismal time to go into EVs. I worked at a high throughput screening biotech company. And meanwhile, friends were starting a long range EV project at school. The idea was to take a solar car that was very aerodynamic, fill it with lithium ion batteries and try to drive from coast to coast on one charge, just as like a wow demonstration. It penciled out that we could do that. I went to the first couple of meetings and I was like, oh, this is solar car all over again. I don't know if I can devote the next few years of my life to this.
So we could spend hours listening to your stories from throughout your startup career, which included your early days at Tesla, which I know must be really surreal when you look back on it. But sadly, we don't have that kind of time today. So instead, I just wanted to focus on what you walked away from that chapter with.
Well, so the technology, I just felt like it was proven when I was at Tesla. I was like, oh my gosh, this is just amazing. The power, the torque, the battery life. But the car seemed so complex. I wanted to take all that technology that existed and put it on a motorcycle where it was more about just a powertrain and nothing else. Really just like pure technological play. And I started Mission Motors. We built an amazing motorcycle. We set a land speed record. We raced on the Isle of Man. It was quite a ride. We were trying to raise money in 2008, 2009, which was a really, really rough time. And that didn't work out. The next company I started was an app for finding electric vehicle charging stations called PlugShare. And that was a success. There were about 60 apps out when we founded. And we did one thing that no one else did, which is we allowed people to share their home garage as a charging station and allow people to charge there for free. And everyone was like, why would people do that? That's crazy. But we had 5,000 people share their home as a charging station, like in the first month of launching. And there were only 600 stations in the whole US at the time, maybe even less than that. So that kind of gave us an edge on the community and really proved to me how powerful the EV enthusiast booster community can be. And that there are people that want things that I want, that Jason wants, like functional vehicles that are not crazy, bloated, sized electric vehicles, charging stations, things that will get us to the next phase. And so after I sold PlugShare, I worked for the people who bought us and they sold that again. And then it's just recently been sold a third time back to EVgo in the US. The other thing related to what we're doing is I worked at FreeWire, which is making battery-backed fast charging. So I've been on every side of the electrification problem. Like, how does it affect the urban environment? How does it affect the grid? One of the reasons we started PlugShare was to balance the grid. So we pivoted actually to the charging station finding app. What I found at PlugShare and FreeWire is that a lot of the grid, just because of the way it's structured, the CPUC and others, they restrict the utilities from making money except for by putting in infrastructure. And so they really restrict that. The infrastructure is pretty much at the edge. It's really hard to find spare capacity in transformers. FreeWire's main point is you could either spend $250,000 upgrading the transformer on the pole, or you could put that into batteries and help balance the grid. And that 6 times a day where a car comes by to do a fast charge, you can dump a lot of kilowatts into that car really fast. But you only have a really small line to the grid, 30 amps maybe. After that, I started a scooter company. That's another story, but that's how I met Jason. Scooter company was kind of running out of gas, and he came to me wanting to build another electric motorcycle. And a lot of people making electric motorcycles come to me and want to talk about the experience with Mission Motors. And so we worked together on making this motorcycle. And then I joined Jason full time to do the motorcycle. And then we pivoted. We had just gotten the motorcycle really running. We were like ready to go out to the world with it. And we kept showing people this one slide that had our master plan on it, motorcycle, small car, truck. And everyone immediately would say, I want the truck. I want the mini truck. So there was one weekend that, to Jason's credit, he went out and just on the street with a clipboard interviewed hundreds of people, and 89% of them said they wanted the mini truck. And we pivoted. Like the Thursday of the next week, we got our first financing. Product
market fit. That's in a nutshell. All right, Jason, give us a little bit about yourself and where you're from.
So I'm actually also from Washington State. That's a little bit of how we actually connected. We actually ended up pole vaulting at the same high school in Washington State. And although we were about a decade apart from each other, if you have ever met a pole vaulter, you know we're all the same kind of crazy. So we all have the same type of views on risk aversion. So I grew up in Washington State in a pretty large town called Bellevue. In high school, I was actually attended a really interesting high school that had like a vocational track to get certified in welding, automotive, stuff like that. But it also had like an APIB kind of program. And most people, did one or the other. And I was one of the few people that ever did both programs. I would get up at 6 a.m. I would go to the vocational school. I was a certified welder. I was in an automotive shop, everything. And then I would take the additional classes that you had to take to get in APIB, all that stuff. But I built my first motorcycle from scratch when I was 13 years old, right when I started high school. And I had no idea how the multi-body vehicle dynamics of a motorcycle worked, or anything like that, but I was obsessed with motorcycles, obsessed with cars. I used to dress as Henry Ford for our Halloween costumes in elementary school. Like, I wanted to be the next Henry Ford. So I was like, I'm going to start with a motorcycle. I grabbed a 200cc motorcycle engine off of some other application. Maybe it was a lawnmower. I can't remember these days. Strapped it into this welded up chassis that I probably had no business welding myself, and 2 bicycle wheels with a 200cc motorcycle engine. Took it out, no suspension, no brakes. Took it out to the school parking lot and just decided to rip it full throttle. And as you can imagine, that didn't go all that well. Cornering dynamics weren't quite there. Rake trail, who knows what that was. So that was a bit of a disaster. And after I picked up the parts of that motorcycle, a couple of years later, I actually built my first 3-wheeled auto cycle. Actually using the same motor that I pulled out of that, but built it into a couple of different products. But I wanted to be different. I wanted to make sure I built something differently. So I built this mechanism that turned the wheels by leaning the bike over instead of actually turning the steering wheel or handlebars. So 2 wheels in the front, 1 in the back, lean the bike over. That's how you actually turn. This was before any other leaning vehicle was showcased on the road. Again, no concept in multi-body vehicle dynamics. Well, the thing cornered pretty cool. The recovery from cornering didn't quite work out all that well. It caused enough centripetal force, inertia, that it just whipped me right off the motorcycle and just kind of skidded across the ground again. So 2 wrecks in, I was like, you know what? It's time to learn how this actually works. And that's when I went to Columbia for mechanical engineering.
Okay. So you end up at Columbia. But did you ever think you wanted to be a founder, starting a business?
I always wanted to be a founder. I really wanted to be the next Henry Ford. But when I graduated college, I took a job down and working in semiconductor, actually. The semiconductor industry was really growing at this point. Ended up actually working on the chipsets for LiDAR and radar. So we developed some of the very first test systems for FMCW LiDAR systems, which was a technology that still hasn't even matured to this day. But it kind of is as the basis for radar and the basis for what is now imaging radar. Worked on everything from the silicon level light to the way we actually steer beams of light, and they constructively and destructively interfere with each other. And it actually became the fundamental technology that is used in autonomous driving today. And that's what kind of brought me from the semiconductor world back into the automotive world. So I actually ended up working with all of the major OEMs, the major automakers, on developing their test systems for all of their autonomous driving and driver assistance programs. Everything from automatic trailer hitched back up to full-scale autonomy. I have a bunch of patents in LiDAR and machine learning test on how we actually go about verifying that you have built a safe autonomous driving or driver assistance system.
So do you remember the day at which you're like, okay, I got to flip a switch and I want to go pursue my own passion?
I do remember the exact day because it was a relatively grim day. A friend of ours had just passed away. This friend was as successful as a startup founder as I've ever met. And he had an unfortunate accident. I remember being at his funeral, just hearing the way other people talked about him. Only the most positive, all the great things he had done and the way that he lived his life. And all I could think to myself is, when I die, that's what I want people to say about me. And that's kind of was the day that I was like, I need to go really, I know where I'm passionate in. I've been working on this my whole life, and I really need to just double down and focus on that. So I'd had just stacks of ideas and notebooks, whiteboards and everything. And I had one I was really passionate about at the time, and it was all around city transportation. I kept thinking, I drive a pickup truck in downtown San Francisco because I have a 150-pound dog. I just couldn't get over the fact that it was so hard to navigate the downtown area. It was impossible. So I was like, well, maybe the solution, because I just came back from Southeast Asia, I was like, maybe the solution is just we should all be driving motorcycles. And if we're going to drive motorcycles, we've got to go electric. And if we're going to go electric, the problem with motorcycles that are electric is the math isn't in their favor. They are not very aerodynamic. For what they do, you would need really big batteries to get them to be actually useful for the American commuter. The American commuter thinks, at least, they need to go 100 plus miles every day, but they also don't want to have a motorcycle that they can't roll up their stairs if they needed to, tuck it away somewhere. So I was thinking, hey, I could build the longest range, lightweight electric motorcycle. Talk to a friend about this, and he goes, oh, you're thinking about an electric motorcycle? You really got to meet a buddy of mine. He's one of the godfathers of electric motorcycles. So he synced us up, and this was back in 2018 or 2019. I can't quite remember now, but I remember sitting in the trailer outside of this specific shop, sat down with Forrest, gave him my life story, and he goes, wait, you pole vaulted? Where did you pole vault? Wait, with Charlie and Tim? And no, that's impossible.
I love it. And I don't want to overlook one thing. The company was originally going to be called Olley. And I'm wondering if you guys could talk about Maurice Olley, a lost hero of auto. So give us a sense of why he might have been an original inspiration.
Yeah. So Maurice Olley is considered by many to be the godfather of multi-body vehicle dynamics. Remember that concept I was telling you about that I didn't quite understand? The reason that I crashed the motorcycle, crashed the three-wheel vehicle, it was because the science of how vehicles actually can operate, all of the complex math and mechanical engineering that goes into how you actually maneuver a vehicle that rides on springs that have to move up and down and turn is a relatively complicated problem. So he built a lot of the math that actually goes into solving those problems. He moved in from the UK to like GM, and he built like the first Corvairs, what became the Corvettes. He is the father of like the 1960s race craze, which was like where you saw all the craziest vehicles that ever were created, from Chaparral to Lotus. They all kind of attribute all the innovations that they had in their vehicle design to Maurice's Olley's innovations that he made.
So give us a story of the name change, where that came from and how that evolved.
I'll actually give you a little bit of the history of the pivot. So I had always planned that the motorcycle was a means to build small vehicles that just completely bucked the trend of what small vehicles were. We were kind of hitting our head on the wall with the motorcycle project. You know, we developed this motorcycle. We really loved it. People liked it. They wanted it. But we had this realization that Americans aren't buying electric motorcycles. 5,000 were sold in all of like 2021. And the reason that is because they don't consider the motorcycles to be like the main source of commute. It's really a hobbyist project. If you're going to do something hobbyist, you know, a lot of people were navigating towards the loud, the fun, the screaming gas motorcycles. There's this connotation that loud pipes are the way that motorcycles should sound and need to sound. And I need to go fill up my gas tank in 5 minutes, not 30 minutes. So we really quickly realized that that wasn't an area that really had a very good addressable market. And we had all these plans anyway to go build all these different vehicles in the future to become this global automaker with all these different really creative, really functional, small footprint vehicles that we just kind of threw it out in the market. And I went and I interviewed a couple hundred people in San Francisco and LA, even went to motorcycle meetups and showed them our roadmap of here's what we're doing. What is most interesting to you? And 89% of the people we interviewed said, I would love to have a mini truck. Even the motorcyclist said something, I could throw my motorcycles in the back of my truck and I can drive to the track on the weekends. I can go park it outside of my favorite bakery on the weekday. That's what I want. That ability to navigate the city streets, but also have the ability to take my kids to the beach. That doesn't exist. That's a huge need, and that's what I want.
So Forrest, when you're introduced to Jason through a mutual friend, what was your first impression?
You know, I was like, could this one work? And one of the reasons I thought that his idea could work was that he was going for a bit of a retro cafe racer. It was kind of an Indian style board tracker from the early turn of the century, last century. And so I thought that was a cool hook, where what I'd done in the past was a sports bike. But then once you get into it, some of the things started to come back up, like the market size just isn't big enough to get VCs excited in the US. It's not that much of a utility vehicle. So then are you really helping the environment? And mostly what I've wanted to do with my career in life is to do something that's going to be positive. The climate crisis is a major concern of mine. I enjoy the environment and the animals in it, and I like not having a burning planet. And when you look at the carbon emissions from the US, for example, it's like 28% in transportation. And the biggest chunk of that in transportation is light duty trucks. We both at some point doubled down on this.
I just want to make sure that that specific stat isn't lost. Like this is actually was a little bit mind blowing. 10.5% of all carbon emissions in the US across all sectors, all economic sectors, are from one thing and one thing only: light duty trucks.
Yeah. Thanks, Jason, for clarifying. Like the truck market is the market in the US, right? It's huge. And there's all these misconceptions about it. Like people think, oh, Americans only buy big stuff. It's not necessarily completely driven by consumer demand. There's an interesting thing out there, which is that the EPA and CAFE standards, they were trying to encourage trucks to get better mileage. So they said trucks of this size need to get this mileage and trucks of this size need to get this mileage by these years. But what's happened over time is that the companies have maxed out what they can get out of engines. And it's easier for them to take the same engine, make a bigger truck. And the mileage is lower on the bigger trucks as per the CAFE standards. They probably could do it if they really wanted to. But their branding and their marketing has all been around bigger is better. And so it's a little bit easier to just follow that line in that direction. So I personally think there's a whole kind of a vacuum that truck bloat has created. And we can fill that hole with a really well-timed, well-produced, well-conceived electric truck.
But what I think is really interesting and I want to dig in on is you guys have such different perspectives on this stuff. So let's start with how you guys perceive your product differently than others who are doing electric trucks.
So there's a couple of different categories. The first category I'll talk about is the market. The second one is the technology. Third one is our manufacturing strategy. Those are kind of the three big things that we're doing really differently. On the market side of things, we're specifically targeting trucks that do work in downtown cities, which there's 20 million of in the US. If you ever drive down San Francisco at 8 or 9 a.m. in the morning on a weekday morning, all you see is pickup trucks because everyone does work in downtown areas and they do construction, they do utilities, they do water, they do everything. You talk to them, they'll tell you these horror stories about how they have to park a mile away from their work site, grab 50 pounds of tools, walk it all the way to their job site, leave it there for lunch, but it gets stolen because they can't bring it back to their truck. Specifically, we're targeting fleet applications that have F-150s and Ford Transit Connect vans in the city. And on the commercial side, it's people that are buying SUVs. What they really want is a pickup truck, but it's too big to actually fit within their lifestyles. On the technology side, I'll let Forrest speak on the batteries because we have a bunch of innovations there. But we're really doing a couple of things really uniquely. One, my background's in sensors and safety, and you might notice that we don't have a hood. We still have about 20 inches of mechanical crumple in the front of our vehicle, but it's not a lot compared to what you'd see on a 4 or 5 foot long hood of vehicles. And the reason we don't have a long hood is, first of all, we don't have a motor, an engine that goes in there. So we have a lot of space to actually do a lot more stuff with. And instead of actually just putting a useless frunk in there, we cut it off. What we actually did instead is we replaced it with a bunch of safety features that are actually going to be safer, not only for the occupants, but really for pedestrians and bicyclists, because trucks kill 3 times more vulnerable road users, pedestrians and bicyclists, than any other vehicles in the market. So we have sensors that detect collisions before they happen. We have cameras and machine learning that classify the collisions after they're detected with a heuristic algorithm. And then we can actually deploy safety inside and outside our vehicle to anticipate collisions and to actually adjust for how those collisions actually interact with what they're colliding with and the people inside the vehicle. Forrest can talk on the batteries, though.
Yeah, and one interesting thing about our truck on the battery side is, there's this been kind of race to get to the lowest numbers in 0 to 60. I personally think 4 seconds is fast enough. I don't need to be sub 2 seconds. Might even be some danger in that. But by not going down to sub 2 seconds, you really change the architecture of the battery and the thermals, and we're able to package it much more tightly. So I think because we're not making a sports car, we're making a truck. We're a little more geared towards utility. It'll still be blazingly fast, amazing pickup, but by not focusing on that as the product metric, we're able to get a much more compact battery. So we're fitting 106 kilowatt hours in our chassis, and our whole chassis it fits in the same footprint as a Mini Cooper. So it's 152 inches long. We made our pre-order price $152. So you're paying $1 per inch to reserve one of these. And there's a few things that kind of drive that packaging, but there's also a lot of learning that I've gotten from all the various battery packs that I've designed that have allowed us to make this very efficient, very manufacturable, very safe battery pack. Every cell is fused. We have really amazing active cooling, and we've made it in such a way that the battery is as safe as I can conceive that we can make it.
I'm curious how you guys view efficiency, because I think it's maybe more holistic than maybe how other EV manufacturers are talking about it or thinking about it. Because it feels like you think about efficiency not just in terms of engineering, but you have this whole vision of efficiency.
Well, at the highest level, when you say efficiency, when you're talking about electric vehicles, the first thing that connotes in your head is around okay, how much are we really saving carbon emissions by moving to electrification? The EPA has kind of tagged this MPGE, the mile per gallon equivalent of electric vehicles. And one of the big problems is going from a gas pickup truck to a electric pickup truck in that same frame. And all you're doing is you're adding a couple 1,000 pounds worth of batteries. So the problem with that is that you've got a really heavy vehicle now that contributes to rolling resistance, which is a huge factor in how you're actually having the energy you have to overcome to drive the vehicle down the road. You have a huge surface area of the vehicle, and you have a relatively unsleek vehicle. So you've got a lot of aerodynamic resistance in that vehicle as well. So all that air you're pushing is a ton of more energy. So in order to get the equivalent 350 miles of range on a big pickup truck, you have to have 200 kilowatt hours of battery pack. So you get somewhere between the equivalent MPG of 50 and mid 60s for a big electric pickup truck. Now, if you compare that to an electric sedan, like a Tesla, you're getting in excess of 100 miles per gallon equivalent. And so we wanted to build a pickup truck with the same equivalent miles per gallon efficiency of a sleek sedan. So we built a vehicle with half the weight, with almost half the coefficient of drag times the frontal area. And we get this result of this vehicle that has very equivalent aerodynamic performance and rolling resistance performance to Tesla's vehicles. So that's core to what we're doing from the footprint and the size and the perspective is like, if you can, now we only have to build a 106 kilowatt hour battery pack to get 350 miles of range. But on top of just the connotation of the efficiency of the vehicle, efficiency of packaging is critical in what we're doing as well. We've got a lot of unique ways we think about how we actually package our vehicle. You might wonder, how do we fit 5 people, a 5-foot bed into the footprint of a 2-door Mini Cooper? Well, it's a packaging efficiency kind of scheme. Like there's a type of suspension called the McPherson strut suspension, and that was initially developed so that they could package a transverse engine into an engine bay because it takes a lot more space to turn the engine sideways than to go long ways. So that's where they developed that type of suspension systems. Well, if you kind of take that to its extreme, you could fit a footwell in that same area. And that's what we do. We fit our footwell of our front passengers right into that area where you might have a transverse mounted motor. And then you can package in the rear passengers right behind them. And then without the space between the rear passengers and the bed, by making that kind of one interface, that the front of the bed is the back of the rear passenger compartment, then you've got an extremely efficient bed lineup. And you kind of stack those efficiencies together and you get what we created.
I'd say there's another efficiency too, which is kind of the efficiency that a company brings a product to market, or in this case, a vehicle to market. And, we've had the wonderful experience of being able to see deep inside lots of different vehicle startups and big OEMs. And there's just so many mistakes and so many wrong paths that have happened. I'm sure we'll make some, but we are trying to take the shortest path from our idea, which we've already gotten traction, people want, out into the market, and not really getting distracted with gimmicks or things that have sent people down the wrong path.
Forrest, you've seen this industry from day one, and it's certainly lived a few different iterations. I just wanted to hear you talk a little bit about how the industry's matured a little bit.
I think one of the amazing things now is so much of the necessary components have been commoditized by big names, and those didn't exist in the early days. Just like powering the low voltage systems, the AC. So those things exist now. Like you can get electronic brake boosters that are just certified right off the shelf from Bosch, electronic power assist units. None of that stuff existed in the past and it exists now. And then on the sensor side, it's really exciting. And maybe Jason can talk more to this, but there's sensors that have just now come to market in the last few years, basically from all that money from flowing into autonomous vehicles that is really something that we can use and that hasn't been used yet. So I would say on the EV side, like the commodities are really mature, the ancillary products, but the big legacy companies are having a really difficult time, as they've always had, moving into a new market because that's not really what they do. Like they are a brand and everything that's around them is focused on that brand. And so to do something new is always difficult for them.
Well, I think it's telling that what we see right now is creating electric versions of the same vehicle, not creating new vehicles, which says something,
we
right?
can totally understand it because once you build a platform, you want to extract as much as you can out of that platform. So we're building a platform and it's a small platform and we're going to make all sorts of vehicles off of that platform.
Yeah, this vehicle becomes a 2-seater 8-foot bed. It becomes a 8-seater SUV, autonomous van, all with just changing the back half of the vehicle.
Yeah. Jason, I want to get your comment on the industry real quick too. As we've watched some of these cycles, the introduction of hybrids and then the early days of Teslas, there have been moments where it's been really, really cool. The marketing, the branding has really captured the zeitgeist of the moment in the American public. And there's moments when it seems like it's not so cool. To me, it feels a little bit like we're in one of those moments where it's struggling to find its coolness again. How do you break through and build a brand that's cool?
So I think that if you look back in the history of electrification, you saw the GM EV1 that came out in the 90s or late 80s even. And everyone thought, okay, there's a lethargic, slow golf cart that can only go 10 miles, And then Tesla came out and bucked the mold. They said, hey, we're going to prove to you that not only are electric vehicles cool, but they're faster than your regular car. They're sexy. They go long range. I'm just going to buck the trend in all ways, building an uncompromising electric car. And that set in motion the wave of which become EV startups following that, right? We're kind of coming out of that wave and people are going, well, is this another Tesla killer? That's, the question that everyone talks about. And the other question that comes up is, how in the world are they going to go compete against the people that are now trying to pivot and build electric vehicles? Aren't electric vehicles $1 billion activity? And then you're getting this, that's why you're in this trough disillusionment a little bit with the EV startups in this space. I think there's still a lot of general excitement for EVs, but they've just become all the same now. It's like just an electric version of the gas car. So what we wanted to do was kind of totally buck the mold, change the form, the function, the size, the footprint of the electric vehicle, and bring on somebody that could actually have that influence to do that. So our other member of our team, Yves Bahar, he is the lead designer here. He's done things like the Herman Miller chairs, one laptop per child, a bunch of work with Prada and other big major names. He's like a world famous super designer. And he took our idea of what we had for packaging and all the engineering and said, here's the design of the vehicle I'm going to bring to market, and it's going to wow you. It's going to be quite amazing. And so we came up with this design. We've launched it to the market. We did that 2 months ago, and the market responded pretty dang well. Like we thought that maybe we'd get 1,000 pre-orders by the end of the summer with the launch we've done. We hit that in 3 days of our pre-order market. So really, really cool. But still, the elephant in the room is, how are you going to bring this to market? Like, how are you going to go from where you are today to a manufacturable vehicle that you're delivering to customers? And the reason that people think that is because of what's happened over the last 20 years. And a lot of companies have spent $1 billion and still don't have a vehicle in market. And that's what, going to what Forrest is saying, like we've seen the last 20 years of vehicles. We've worked with many of them. And we've been in Detroit. We've been in the Bay Area. I've even spent time overseas in Europe as well with a lot of the automakers. And there used to be this huge divide. Silicon Valley thinks this way. Detroit thinks this way. Europe thinks this way. And only now is it all kind of coming back together. People are trying to start to appreciate the difference in perspective that a lot of people have. And I think that's what's going to be the catalyst to actually bring vehicles to market at a full order of magnitude, less money than before. So where companies in the past may have said, hey, I need to go spend $100 million on steel stamp parts to go build a million vehicles before they even have a single vehicle in the market. Now they can spend 1/100th of that and deliver 500 vehicles the first year. And there are things like that happening. And you add in contract manufacturing, both from a low volume perspective and from a mid volume perspective, you can actually scale with your growth as you go. You don't need to run before you walk. And that's exactly the implementation that we're using as a company, walking before we run.
Forrest, you mentioned your passion for this. How do you think about how you guys look at the opportunity for the company to do good for the world while building a good business?
One of the things I think about is durability. Having a vehicle that is a utility vehicle and that really lasts a long time is an important factor in reducing the carbon footprint of a vehicle. So going electric is great, but also not junking the vehicle after a few years or needing to change components. Vehicles have gotten kind of bloated, both in their size and also in their features in the interior. There's just like a lot of trim pieces that when we've looked into the costs and how you make them, they're not sustainable materials, first of all. And people really don't even notice them. That's what's kind of crazy is that if you ask someone, do you really like that piece of decoration on your dash that is a faux wood grain? They probably don't even know that it was there. And we have, I think, the opportunity in making a utility vehicle to focus a bit more on making something utilitarian, which we're excited about. We haven't released the interior yet, but that's something that we're thinking a lot about.
Yeah. And Jason, what do you think needs to change about the conversation around EVs and sustainability? What are people getting wrong around the positive impact it can have? How do you think about it?
Big thing is the actual carbon footprint of transportation is massive. It's over a quarter of all of our carbon footprint. There's a lot of people, you ask questions, they go, what about big container ships? And you go, well, yes, they're huge and they do emit per unit significantly more than any other vehicle. But the sheer quantity, the 46 million trucks that are in the US way outweigh the shipping. I think the conversation needs to be had around what can we do differently to actually have the biggest impact on our carbon footprint in each of these categories? And that's why this particular problem is so enticing to us.
While we're talking about doing good and building a good business, I think there's one other element. Jason, I heard you mention it, safety. Would love to hear your take on how you're designing to do good for the world, not just environmentally, but also from a health and safety perspective.
When everybody talks about the automotive deaths, they always talk about the 36,000 people that die in their vehicles from crashes every year, which is a huge problem. And that's why the autonomous vehicle industry got stood up to solve that problem. But what they don't talk about as often is the 8,600 people that get stricken by vehicles as pedestrians or bicyclists or scooter riders that died last year, higher than any other year that we've ever had in history, being driven partially because of the sheer size of trucks. Like their hoods are too tall, blind spots are huge. And when they do strike somebody, they strike them at such a high point that the outcome's grim. What we're looking at a lot is how do we continue to solve the problem of making crashes more safe, but how do we prevent crashes from happening and how do we prevent crashes from actually injuring people outside the vehicle. And so those are really the areas of focus that we're focusing on. Now, we haven't really launched the technology that I'm alluding to here, which there will be a launch in the future that talks specifically about what we're doing there. But just note that like we look at the things like how do we optimize for a collision for a pedestrian? If a pedestrian randomly jumps into the middle of the road and it's unavoidable to hit them, how can you make sure they have the best likelihood of surviving that incident?
I was just going to say, I was in the scooter industry for the last few years, and cities really exerted a lot of control over scooter companies because they were dealing with this kind of new transportation. A lot of it was around safety. I feel like vehicle companies have gotten a total pass on vehicle safety in cities because cities can't really control it. They can say, if you're Bird and you're coming to this town, you've got to pass our permit. But they're not saying if you're Hyundai or Ford, you have to make your grill this height. And I'm not sure that's going to be like that forever, especially as you see these growing dangers. And even just outside of the danger, just the urban environment, back to kind of my beginning, I went down a street that I used to live on that was a really idyllic street in Redwood City the other day. And it had big trucks on both sides of it because there's a lot of construction going on. The street just totally felt different. You couldn't even see the houses because you can't see them past the hoods of these trucks. It just makes the urban environment have a different and more menacing feel. At some point, people are going to push back against that. People can't push back unless they have options, and we're going to give them an option.
The last question I tend to ask is, what do you hope your legacy is?
I want to be remembered in textbooks as someone that changed the way we move around the world. When you look at the history of transportation, mobility, automotive, I want there to be a chapter on Jason Marks.
That's awesome.
That's succinct. And Forrest, what do you have for us?
Yeah, I would love to be part of the moment in time where Americans start to relish small cars again.
Consensus in Conversation is hosted by me, Connor Gahn. The episode is produced by Will Gatchell and Jeff Rock. Executive produced by me with editing from Reasonable Volume. Special thanks to Consensus Creative Director Kate Tucker, Greg Harrigal, and strategist Patrick Gallagher. Don't forget to like and subscribe on your favorite podcast platform. And we'll see you next week.